All right, today we talk about some parts of a circle. First thing, one of the most important things is a central angle. Is an angle whose vertex is the center of the circle. Here the center of our circle is circle O, right here. And you see this blue angle, angle BOA. That is a central angle because the vertex of that angle is right there at the center. It measures 70 degrees. Well, there's types of arcs, right? This part of the circle, parts of the circle are called arcs, right? They're not segments because they're not straight, they're curved. So if I asked you to walk from like point A to point B, there's two ways you could go. If you could go from point A to point B. You could go the short way, right, from point A to point B, just like that right there. Or you could walk all the way around the old long way if you really wanted to, and that would be another way to get from point A to B if you had to stay on the circle, right? Taking this blue path, walking through a radius, you didn't stay on the circle. So the short way around is called the minor arc. So that's written as arc AB with two letters, and you just put this little arc symbol above it, right? It's nice and curved. It's not straight, arc AB. And then the long way around is called a major arc, and that's got to be written with three letters so you can tell which way to go. And when we walked from point A to point B, didn't we come across point C? So they'll use three letters, arc ACB, right? And that's how that's written. The fact about minor arcs must measure less than 180 degrees, right? So they may actually use three letters to name a minor arc. You just have to tell by its measurement if it measures less than 180 degrees and more than 0 degrees. That's a minor arc. A major arc, since it's the long way around, that would be written, or that would measure more than 180 degrees. So what happens if you actually had a 180 degree arc? Well, that's called a semicircle. It's basically where you got yourself a diameter here. I'll add some stuff to this picture. Let's put a point X and a point Y, and that's a diameter. A semicircle is half of a circle. It's 180 degrees, meaning if I was to walk, if I could find my highlighter, from point X to point Y, it doesn't matter which way I go. If I go the red way or if I go the green way, it's the same distance because that was a semicircle right here, and this was a diameter. Each one of these arcs measures 180 degrees, and remember, of course, there's 360 degrees possible. So when it comes to the measure of an arc, if you know a central angle, which we do right here, that means since this is 70 degrees, a fact is that the arc that's contained by that. So here's the central angle in green right here. Isn't this arc right here in red completely contained by that green angle right there? Any arc that's contained by a central angle will measure the same amount. So you'll say the measure of arc AB equals 70 degrees. You do the same thing just like an angle. You put a little m in there for measure. So the measure of an arc has the same as the central angle contained by it. And then the last thing before we get started on our practice worksheets are called concentric circles. Con means same, centric means center, so they have the same center. It's circled in the same plane with the same center. And the funny thing about it is arcs can measure the same amount but be different sizes. So like you see, here's a central angle. If O is the center of the circle, this blue thing, angle AOB, is a central angle. The measure of arc CD is 80 degrees, right, because that's contained by it. But same thing with the measure of arc AB is also 80 degrees. And those two are completely different sizes. So today we talk about arc measure, and we also talk about arc length later. Obviously, the red one is much longer than the green one. If you was to walk from point A to point B, you would walk much further than when you walk from point C to D. So arc length and arc measure, two different concepts right here. So let's get started on our practice. I guess here's another example. Let me get this out of the way. It says use circle O at the right, which the measure of arc BC equals 40 degrees. So if they give us information, we put that in the picture. I know you don't have this picture. I'd just like you to watch, though, and see how easy these problems are. And the measure of angle COD is 90 degrees. What we'd like to do, instead of answering all these questions, the easy thing to do is find everything in this picture that you possibly can. And there's some help. The circle's best friend is this guy right here. That's a diameter, right? And a diameter splits things up into two semicircles. It measures 180 degrees. So if this angle is 90 degrees, then this is its linear pair. That's also going to be 90 degrees. we know that since this arc measures 40 degrees, the central angle contained by it, and O is the center of the circle, should also measure 40 degrees. And then by way of linear pair right here, these two have to add up to be 180. This has got to be 140 degrees. And then this arc should be 140 degrees by way of that's a central angle and that's contained by it. This arc should be 90 degrees and this arc should be 90 degrees also, because these are all central angles. So now I filled out everything I possibly could in the picture. Now let's see how easy it is to answer these questions. So find the measure of angle BOC. Boom, 40 degrees. Done. Measure of arc AB. Got it right here. 140 degrees. And that's a minor arc because it measures less than 180 degrees. Measure of arc BCD. That's the long way from B to C to D. I'll highlight that for you, from B to C to D. That's the order you're supposed to go in, the way they wrote it. So we can add those together and get 130 degrees. And see, that's still a minor arc because it measures less than 180. Even though they use 3 letters, they just wanted to tell you which way to go by using those 3 letters, because you can go from B to D 2 different ways. So they went from B to C to D. And the measure of angle BAC, that's from B to A to C. That's all the way around from there to there. The whole thing is 360 degrees, so you could add up to 140 and then 90 and then 90 and get your answer. Or you could say, oh, it's 360 minus 40, which is 320 degrees. And yes, arcs can measure up to 360, right? They don't have to be 180 or less. Arcs can be up to 360. Angles, though, can't be more than 180 degrees. So, and there's no clockwise or counterclockwise. That doesn't have anything to do with it, right? All of these are positive answers. It doesn't matter which way you go around. So now to our practice sheet. Find the value of x. Well, these are all central angles, and you're only missing one, so you know that all of these must add up to 360 degrees, because that's how many degrees possible in a circle. So we take 360, take away 105, take away 60, and take away 115, and all that's left is 80 degrees. So we'll put it in a picture. And then you can see that this is 90 degrees, this is 120, so 360 minus all of those leaves you with 150 degrees, so we put that in the picture. That's really going to help us this chapter if we put information in the picture. They say that these two segments, boom, boom, are diameters of the circle O. First tell me if it's a major arc, a minor arc, or a semicircle, and then find the measure. So what I do first is I'm going to figure out everything that I can in this picture, then go back and answer these questions. This is a central angle of 44 degrees. This is its vertical angle, so that's also got to be 44 degrees. They told you this was a diameter, meaning 180 degrees possible. That means that these are a linear pair. So if this is 44, that's got to be 136 degrees. And this is its vertical angle, so that's 136 degrees also. But all these arcs out here, they're all by central angles here. So this is 44 degrees. That's got to be 44 degrees. 136 degrees, 44 degrees, and 136 degrees. I took 1 minute of my time to fill out everything that I could in this picture. Now watch me answer these questions lightning fast. Measure of arc BA. This guy right here, first, that's a minor arc because it's less than 180 degrees because it measures 44 degrees. So I just throw an equals 44 degrees. The measure of arc BA equals 44 degrees. Measure of arc BC, right here, 136 degrees. And that's also a minor arc because it measures less than 180. Measure of arc CD, that equals 44 degrees, and that's a minor arc. Measure of arc ACB. Just because it has 3 letters doesn't mean it's major. We got to look from A to C to B. So my highlighter, from A to C to B. That's the order I had to go around. So that's all of the circle except for 44 degrees. That's going to be 316 degrees, and that is definitely a major arc because that measures more than 180 degrees. Measure of arc BCD, from B to C to D, that's right here. Well, that's a semicircle because it measures 180 degrees. And measure of arc BD, right, BCD, yeah, okay. And then measure of arc BD is also a semicircle because it doesn't matter which way you go around. So They kind of tried to get a little tricky, that's why I got confused, but semicircles measure 180 degrees. And then here, reading the pie chart, you know there's 360 degrees possible. It says the graph shows the results of a survey taken by diners relating what is most important about restaurants where they ate. Find the measure of all these arcs. Well, they give you like the percent right here that it's taken up in the old pie chart. So all we got to do is take our calculator and they're like, let's figure out the measure of this arc. Well, that's 56% of the circle. So 56% of the circle as a decimal is 0.56, and the whole circle is 360. So that means that this right here measures 201.6 degrees right there. Then here, 11% of the circle, 11% times 360 would be 39.6 degrees. That's how much this particular arc is right here. Why don't you pause the video and find these other three arcs right here, how much they measure. Just take the percent as a decimal times 360. And I got those done, and what I'll do is I just quickly double check that all of those add up to be 360 degrees. That's how you know it's 100% of your circle. Find the measure of arc AB. Well, where's A? There's an A. I covered it up. Arc AB right there is 79.2 degrees. Measure of arc BC is 28.8 degrees. Describe the type of arc, so they mean major, minor, or semicircle, that the category of great food. Well, great food is 201 something or other degrees. That's got to be a major arc because it's more than 180 degrees. And then arc length. Arc length right here is the part of the circle, like how far it is. They're using this cursive L. I don't like to use that cursive L. I like to use like arc AB or something like this, arc AB, just generic two letters, whatever the two letters are. Like, if you don't have the M in front of it, it means you're finding a length. If you do have the M in front of it, it's a measure, and that's like the degrees right here. So arc AB equals x over 360 times 2 pi r. Well, like, pretend for a second that they wanted you to find the length of arc AB, if my pen would work. Like, how far would you walk, like, in an actual distance from point A to point B? Since they use two letters, you want to go to short way, right? And here's the thing. We need to know the radius of the circle, and we know how far it would be if we walked all the way around. That's the circumference, equals 2 pi r. The circumference all the way around would be 8 pi, right? We'd walk 8 pi inches all the way around. Well, we don't want to go all the way around. We only want to go 80 degrees out of the possible 360 degrees. So that's why we figure out what that is as a percent. 80 divided by 360 is, if I do that, 22.2% of the circle. We only want to walk 22% of the way, so we take that percent times the distance all the way around. That's why the formula is this, x over 360 times 2 pi r, where obviously 2 pi r is the circumference of the circle. It's like, here's the circumference. X stands for the central angle measure right here. It's like, how many degrees out of 360 do you really want to walk right here? So let's give these a try. It says use circle O and find each arc length. Round to the nearest hundredth. So first thing we'll do is we'll write the formula down. They're looking for the length of arc DE, and that'll be x over 360 times 2 pi r. They give me this information. The radius is 2 meters, right? And they want arc DE. Well, let's fill out the rest of this information right here before we get started. We know that this is going to be 120 degrees. Here's a diameter right here. So if that's 45 and that's 120, then what's left for this in here is going to be 15 degrees, and that's hard to put in that tiny little picture, so I'll just put it right there. And this is 90 degrees, and this is 90 degrees due to that box, and this guy right here. So they're going to change the information on us back and forth. We just got to go one question at a time. I need arc DE, so I know the central angle measures 120. So, the length of arc DE is going to equal 120 over 360 times, if the radius is 2, I'll do a little bit in my head and call that 4 pi. Well, punching this in the calculator is the hardest thing to do. So if everybody does it the same way, we'll be good. The first thing you do is punch this thing in your calculator. Take 120 divided by 360 and hit equals. And you get 0.3 repeating. Well, we need to take that times, we need to take that times 4 pi. So I will take that times 4 pi times 4 pi. And you see how I just took that previous answer, and there's my answer. They want that rounded to the nearest tenth, so it's about the length of arc DE is about 4.19. And then the label is meters, because it's just a length, it's not an area or anything. So let's do that again, but they're going to change things up on me. First they give me the diameter is 7 inches, so very fancy right there. Arc DEA, the length of it is going to be x over 360 times 2 pi r. And arc DEA, I know it gets old to write that formula down, but please do that. Arc DEA, that's from here to here to here, from D to E to A. So I add those together and get 210 degrees over 360. And the diameter is 7 inches. Well, that's 2 times the radius, so you can just straight put 7 in for 2 times the radius, you know, because the radius is 3.5. You take it times 2, you get 7 again. And now we punch it in our calculator. Type 210 divided by 360 and hit equals. And then take that times 7 pi. Maybe. And get 12.83 inches. So the arc measure of arc DEA, the length of arc DEA is about 12.83 inches. Let's do another one. Arc BC's length, x over 360 times 2 pi r. They say the distance from B to E, which is the diameter, right? So I'm going to say that that's my diameter. I'm going to put a D right there. It's 24 feet. And arc BC, its central angle is 45 degrees, so that's going to be 45. Go in for x. Times the diameter times pi. Right? So we'll punch that in. 45 divided by 360, hit equals, and then take that result times 24 pi. 24 pi. We get about 9.42 feet. So why don't you pause the video and set up number 4 right here. So the central angle of arc CBA is 135. Right, here's the 45 and the 90 put together. The radius, they say the distance from D to O, which that's the radius, is 3. So when I substitute that in, I got to take it times 2. And then I'd type 135 divided by 360, hit equals, take it times 6 pi, and I should get 7.07. So that's arc length. Your homework is all from the book, section 10.2. Let's do problems 12 through 51, all of them right there. So let me know if you have any questions, and have a good one.